Bogibeel Bridge itself has been proposed as part of the Assam Accord between Government of India and the ASU leaders in 1985. From 97 onwards to till 2007, there was paucity of funds. Finally, the central government declared the project as a national project.
Indian Railways have had a long history of constructing lines in difficult terrain, bridges in unexplored rivers, lot of firsts to its credit.
Dibrugarh, as we all know, it is a very important city from the strategic importance, especially with the Chinese gaining prominence on that side of the country. So we required a connection, a method of crossing the river, the Brahmaputra, so as to have access to Arunachal Pradesh.
This region is one of the richest regions, not only in the country, perhaps in the whole world in terms of resources, whether it is bioresources, whether it is mineral resources, hydro resources, just name it. Great impact in terms of socio-economic development of the entire region. Not only just Assam, South Bank, North Bank, but beyond.
So for the superstructure, we have done some modifications. General pattern is the same, but we have used the latest technologies in order to improve the superstructure.
Here, nowhere any bolt or any rivet has been used. They are all welded. All members are welded together. Being fully welded, we avoid the use of rivets or bolts, which makes it much lighter. We have designed in such a manner that the road deck, which is of concrete, plays a part in sharing the load coming over that bridge.
Problem with the river is that when it is in spate, it creates a lot of what we term as scour. Scour is the removal of soil near the foundation. So the well foundation, because of its massive nature, because of the depth to which we can build the well foundation, is eminently adapted to withstand this particular flow of the river.
The location of the bridge is such that we don't have any stable banks from which we can start the bridge. That's why we need to have an artificial one, which we call guide buns. On the south bank we have a guide bun which is 2 kilometers long, and on the north we have a guide bun which is almost 2.8 kilometers long. See, the launching of the Bogibeel Bridge is unique in itself. That is why we have to erect the entire girder, assemble the entire girder inside the workshop, and then we pull it outside the workshop by incremental launching methodology. And for that, we have to have a launching nose that will take care of the deflections, and we need to have a launching tail also that will take care of the deflections.
Challenge here was that we could only have built a workshop here on one shore. So launching could be done only from the south shore. This was a big task here, and that means whole manufacturing must be done on one shore, and we have to move the bridge, the whole bridge, every truss girder from south shore to north shore.
We are doing the incremental launching by means of hydraulic jacks, which are installed at every 10th pier.
Weld, we used submerged arc welding, we used gas metal arc welding. So these are the few modern methods used in fabrication.
The success of a project depends upon how you choose your team and then build up that team. So the focus should be to mobilize and build up the right team in the beginning of the project. Once your team is in place, then the project will automatically follow the path.
The teams required special training. These teams required special style of functioning to adopt the new techniques being learned.
We have employed around 22,000 to 2,500 people to work in this particular project, and this 2,500 people consists of all the skilled, unskilled, technical, all these manpowers. Other than this, we are having around 150 to 160 number of engineers working round the clock for day and night shift.
So the railway engineers who are posted at these projects, they should have a continuity of tenure. A person has to be associated with the bridge, he has to grow up with the bridge, and therefore he has to put his, because it's not a simple job. It is a time-consuming job, and it requires a lot of sweat and blood.
Construction of a bridge on Brahmaputra itself is a very big challenge. It required something like 2 million cubic meters of boulders.
The structure is massive, and the guide buns as well. The guide buns are also massive. The quantity of earthwork, the quantity of boulders involved in the construction is huge.
And construction had to be done in one working season of about 4 to 5 months.
We were using new technology where there were no IS codes. So we had to go into the Euro codes. Euro codes were not very well understood. A team was there which was able to work around the clock and finally get the desired results.
This project has been awarded DLSA Quality Award by the Quality Company of India for the prestigious work we have done for controlling belt repairs to the 5%. This award means a lot for SEC, for all of us, for this team. And for the years to come, this team can cherish this award.
By shifting over to welded construction instead of riveted construction, we are opening up entire vistas of knowledge. In fact,
the closest way to get to people is through a smile, an open mind, and a laugh. And I must say that during the design process we started in 2005, it has been a pleasure to work with Indian people because somehow they have a kind of the same humor as we have in Denmark.
And I recall the first day I landed in the riverbed, and I could not visualize how the bridge will come up at this position when there was nothing. I'll say it has been the most satisfying period of my career of having created something out of nothing.
I took over as general manager when the project was in a very advanced stage of construction. A very rich experience as far as I am concerned personally.
When the bridge was complete, I had the occasion to drive across and had a lovely and excellent feeling that time. And after the inauguration, when I saw lakhs of people on top of the bridge, the smile, the happiness on their face was really fantastic.